I'm Lars.
And I am Franz. And we're here to
unbox
you up.
Oh.
Hey y'all, it's Dr. Know-It-All. I'm back with Dr. Scott Walter, not Lars and Franz. Many apologies to Lars and Franz. We just thought it would be really funny to do that intro. So hopefully they'll laugh with us, and not get mad at us and never invite us to any more events ever.
Yes. Hopefully it doesn't happen. However, their presentation did get me pumped up.
That is true.
No doubt about it.
Unboxed.
Yes. And I think they also pumped.
Yes,
also pumped and unboxed. Yep.
Okay. So we are going to talk today about unboxing, I guess. Basically, the new way that they are doing cars with Generation 3, whatever the next gen vehicle is, which is pretty darn cool. So I think let's go ahead and share the screen, and I will try to find the spot. I've been having problems downloading this because it's just too big. So again, I'm on YouTube. I'll put a link to this in the description so you can see it if you're interested. But now that they've put chapter markers, this is a little bit easier. I think it's towards the end of the presentation where they actually go through the...
Somewhere right around the middle of their chapter, I think.
Yeah. Okay, here we go.
A little bit before that, Or actually, you might want to go...
No, this is the current way of assembling a vehicle. So you put it together.
Yep.
You put it together, then you paint it, which I think, body in white, then you paint it.
Right.
Then you take it all back apart again, and then you squeeze all the pieces together, and you like put in things and put in things. And as they said, it's not nearly that simple, because you saw that just violated physics. It just went right through the roof.
Right. He was saying it's not that easy. But you do see there's a certain amount of complexity. Look how hard it is. Look, you can barely fit those things in.
Right.
That's a tight squeeze.
Right.
And everything else you're doing there.
Yep.
Now, I think there was like a slide a little before that shows how linear that process is.
Okay. Oh, yeah.
That shows just before that.
Is it just before that?
Oh, okay. We just saw, right about there. Okay. Engineering design.
No, I think actually the one you're looking for is right after this.
Is it right after where he shows the linear?
No. Where is that? I
think it's just before it. Just before. Yeah, just 10 seconds forward it a little bit, and I think we'll get to it quick enough.
So like after or before? That's what I'm trying to remember.
Yeah, keep going. Let's see. Okay. Combining the, I think it's right just after this. A little bit after that. It's probably a minute after that.
Okay. So anyway, I'll put this on and we'll let it run. But as is obvious, even from that computer rendering, this is let's call it suboptimal way of putting things together. So Scott, first of all, we should probably explain why it is done that way, because it seems so illogical. So what's the reason why up until now cars have been built this way?
Well, they pretty much explained it that's been the way it's been done for 100 years since they came up with the assembly line. Right. And there's going to be this, that's it, stop right there. That's the one we want perfectly. So this is the current way. And the thing is, at first you have to stamp all the parts together, and then you have to put it together, and then you have to paint it, because you can't paint it before the final assembly. And so that sort of just determines how linear the process is, because think about it, you can't do the painting before you really weld it together. Right. So you got to get the welds out of the way before you can do it together. And that sort of dictates it. Plus the fact that you have these different fiefdoms within the OEMs that are responsible for stampings and body and paint. In many cases, the stamping shop is another plant somewhere else completely. Right. It's not where final assembly is.
And it could be a first tier supplier even. Like it doesn't even have
it could be. So they're miles away easily, 10s or 20s, and they might have like a dedicated freight rail that will come in, or by bus or something, or truck, to bring those things in to the final assembly, where they will then weld together and do the paint and everything else. So because of that, you have these different groups that really don't care about one another. Just so long as I do the stampings the way I'm supposed to, that's how it's done. And so you've got this very linear process that sort of dictates how everything is done. And the paint is the one that I've always felt has been the bottleneck of the whole process, because it takes a long time. And anyone that's ever built anything, anyone who's been a carpenter or something like that, the part that you hate the worst is the fact that you have to paint something. Right. And in some cases, you have to paint it first, let it dry, and then maybe you can do some final assembly. Right. So and because obviously you don't want to have to mask everything off. And if you've ever had to rework your car, all the masking and everything, it's just very, very difficult. Right. And this is like like the hint that I put out the other day. Now, once again, I'm showing you that prototypes are easy, production is hard. Okay,
Right.
So this T-shirt prototype is really crazy. And, you might want to blow it up.
Wait, just so people, can see this better.
There we can go. All right.
The best solution is no problem. We're going to make a shirt. This is going to be a real shirt with this on it.
So here's the prototype. And the dots you see down here is an homage to dots, connecting the dots, because he sort of got my gears turning on this, because he was talking about the idea of a dry factory.
Right.
And what's the wettest part of a factory?
Yeah, it's the paint shop.
The paint shop.
Yeah.
If you can eliminate the paint shop, that's your solution. So I'm saying get rid of it. Now you don't have the problem anymore. The solution is get rid of the problem.
Yeah.
And so,
which is what the Cybertruck is doing.
Yes, the Cybertruck is doing that. And this also, I think, is reducing it a little bit.
Right.
And they are going to be pretty close to maybe getting rid of the paint shop completely.
Right.
And my thesis on that has been majority of people don't really care that much about the color of their car. Because if they did, you would not see so many white cars and gray cars and quote silver cars, which are really just gray cars.
Right.
The colors of cars that are generally out there are very, very drab. It's a minority of people that really care about it. And there'll be something with wrapping.
There's a tendency that they're more expensive cars that have the more.
The tendency they're more expensive. So if you're getting down there, I just need something that transports me reliably and doesn't rust out in the wintertime. That's all you really want. And you'll wash it every now and then. You don't really care if it's painted. You just care that it's corrosion resistant.
Right.
And yeah, maybe you get a little bit, but most people are not as picky as you think. So if you can come up with some way of getting rid of it. And my thesis has always been, it's typical. GM leads the way. They get 95% of the way there and they drop it. The Saturn had plastic side doors.
Right. Right.
It wasn't all plastic. They had metal where they needed it, but they were being able to do that. And they were just like, we can't quite perfect the process, so we give up. And they were like that close.
Same thing with the EV1. They had a great product. It was like wonderful.
Yeah, they had a great product and they scrap it. And so, and the Pontiac Fiero evidently was the same thing. They were this close to really making it a success and they just decided, boom, that's it.
Right.
So my feeling is that you're going to see a lot of new things when it comes to coverings and the outers and skins like that. But that's like a divergence of what we want to be talking about here. So that's the whole idea.
But it really does matter though, because what we're going to look at here is that the sort of dictating part of the entire assembly line is painting the vehicle. You have to put it together. You have to weld the parts together before you can paint it, because you can't paint and then weld or else it destroys.
Right. Yeah.
So you have to do it in this order, and it's serial, which means everything has to happen.
Has to be done that way.
It has to get put together, painted, taken back apart again, put back together again.
Yes.
Tesla's going to do is modularize that and
right. Now, as he shows, and did we just show that? I think we did that. They paint it. And then they take the doors off, and later on they put the doors back on.
Yes.
Now,
I'll go back.
Why do they bother putting the doors on there in the first place? When it goes to the paint shop,
it's got to match.
It's got to match. Yeah. I mean, just because it's red, we have a bunch of them that are red. It's really hard to match the paint. Right. So you're sort of forced to put the doors on there just to get it to match. The other thing is the question of whether you're overpainting, whether they're painting more parts of the car that don't need to be painted necessarily, but they just happen to be there. And they're sort of looking at it from that standpoint. Yeah. So there's going to be some really big changes. And again, the best process is no process, and the best solution is like no problem, right? It's like get rid of your problems and you don't have to worry about solutions.
Right. So here, just to walk this through again, you put the parts together. This would be where the welding would happen. You'd spot weld.
That's where all the robots go around all over the place.
Spot weld.
Then
you have to go in and you white coat it and you paint it, and then you take it apart.
It does a bunch of dipping. You paint it several times. You got to put the base coat in, then you put the color coat, then you put a clear coat, and then you got to bake it. You do everything, and it's like this really long intestine that you have, because it takes a long time to go through the whole shop, and that is what is really can be the bottleneck. And in many cases, you'll have problems in the paint shop that will cause the serialization of the line to change, which means a lot of times when it comes out of the paint shop, they come out in a different order than they went in. You wish they would come in and out at the same, but then that can mess up the just-in-time inventory on the other side. So it creates headaches like crazy. And again, it's like, well, now we're going to take the doors off, and now we're going to put them back on again. Really? Just because we had to paint the thing?
I mean, as a really rough analogy, it would be like, let's say you needed to bake a bunch of cookies for a bake sale or something, and you were required to take each cookie, put the dough on the thing one at a time, put it in the oven, let it bake for a while, take it back out again, rearrange the cookie, put it back in one at a time. It would
take the chocolate chips out, do something else, put the chocolate chips back in. You know, it just doesn't make sense. And you know, looking at that is from the scale of the giga castings, you know, you really understand what that saved. Is that if you can eliminate the paint shop, that is also of the scale of the giga castings. And that's one of the things that people, and I think there's a road. There's a road for them to be able to do that here. People still don't understand that with the Cybertruck is, even if it's really difficult to work with this, by the way, very corrosion resistant 30X stainless steel, that just getting rid of the paint shop is going to optimize the assembly line so much. So anyway, so what they're going to do here is they're going to go to the cookies. You put all the stuff on the individual chips, you bake the cookies, and then they're going to put the cookies together. So I guess, but you're doing it all at once. So you're parallelizing the work. So it's probably not the best analogy in the world, but it's what came to mind immediately. So, so anyway, they talk for a while. Let me see if I can get to the part where we get to, okay. So here we get to a slide, which I think is really, really valuable. This is another thing. What's it called? Space-time efficiency improvement. Yes. So, the other I'm trying to remember. I think was there a slide just before this where he showed how they're changing the process? Not a little bit before, because there's a before and after. If I recall, I think he shows how they now are going to turn it more into a parallel process than a serial. Right. Yeah, and I don't remember what that information in that slide pops up. So let's see. Of course, Lars and. And I should be running this at double speed so we can get when he talks about the overall process and what they're going to be doing, and in the parts of there he talks about the parts that need to be painted. Right. And so here he's showing how they were able to make improvements by realizing that the floor is part of the car, and then which is going to be where the batteries are, and the idea of mounting the seats directly to that and having it going up, and they already saved at least 10% right there. Right. And this is on the Model S and Model X currently. So yes, it's on for the structural battery pack. And so now you can see what they do is they just go just drop the top on the bottom and they're done. Yes. So that makes it a lot easier in the final assembly to be able to pop everything in there. Right. But they want to be able to make more improvement on what's going on here. Right. So you're seeing how the entire car body goes through this very long process. This conversion. Okay. So it does. It definitely switches. I think the slide you're after is after this one. Maybe it's going to be right after. Yeah. But anyway, so one of the other things that we've got here, of course, is when the entire car is assembled, there's only so many people that can fit around the car and do functional work on it. Like you can see, there's like dead spaces between these human or Optimus bodies. Or a humanoid robot. If you haven't seen that video yet, you should definitely watch it. I'll put a link to that up here. But anyway, so there's lots of dead space, or you have to have more employees working on the car simultaneously. Yes. So what we're moving towards here is to modularize it, just to build pieces of the car. Now, of course, the downside of this is, how do you paint it? How do you spot weld the pieces together without wrecking? This is going to be interesting. And this is where I'm waiting for Sandy Monroe to weigh in. If we get to the next part of the video here, which I think might be coming up. If we have this was one of the things I just imagined Sandy sitting there at Investor Day going like, what? Oh, he was giddy about it. It was absolutely, he and Corey said that. So, talking over that, it should be coming up pretty soon. There we go. That's the slide I was looking for. I think if we this is the one. Fast forward a little bit there, right there. Okay. There we go. So parallel. Yes. So you've removed a lot of the stamp shop by turning it into castings. Right. And we can see that the floor or the battery module is not going to be cast like a lot of people thought. That's going to be stamped. And it does make sense because it's already kind of a single part right now. It's very easy to do. Where the underbodies, you had so many different parts that need to be welded together. It made sense to go to the casting because of the complexity. So there's a front and a rear and an other, which is rather interesting. I'm not sure what that other is going to be, but that's interesting. So you have the stamp and paint, and then you've got the vehicle assembly. So all these things can be done more in a parallel fashion where they end up feeding that line. And just to point out, say paint the parts which are necessary. Right. And that's a key to me, that they want to reduce the amount of painting that's going on. Well, I mean, you even notice that with the casting is that if you look back to the original thing, they put the traditional way of building it, you put the whole body together, then you paint it, which includes all of those parts. Everything. Now you don't have to paint that stuff anymore. That's not necessary. And paint is wasteful. You've
Yeah.
got to clean it up with all the solvents.
And it's
And
also
so if you're using this
toxic.
process,
Very
yes.
toxic.
Now remember, down in Mexico, they're talking about the fact that they have a water problem. Well, already they now have a process where they're probably going to use a lot less paint, which means a lot less water,
Right.
and everything else. So they've thought this through.
Yeah. Yeah. I'm sure
Yeah.
this was something that Elon probably gave him this slide and said, look, this is going to save a ton of water. We won't have to use so much water.
And they can probably recycle the water and everything else anyways.
Yeah.
So
yeah, exactly.
which they have to. They just cannot take the water and dump it anyways. It has to be treated.
Right.
And so there's probably just a slightly another level of treatment, and then you've got a closed cycle.
Right. So yeah. So this is the, but you know, so we've gone from like this kind of thing, the long snake, where any one bottleneck just disrupts the whole thing, to now I'm just thinking of an example, like let's say this left side upper body thing there's a problem with it in a given cell. Well, you just let those guys work on it and fix that problem. You substitute another one in, and the assembly line just keeps on going. So instead of one long snake, you've got this feeding sort of thing that's happening, which is just amazing.
Right. So as we go along here, we're going to see the animation of how that process is going to play out.
Right.
And it's a very interesting step or process that they're doing here.
I'm trying to catch it as it happens. I think it happens right here.
The unboxing process. Okay,
so this is called the unboxed process.
The unboxed, yes, the unboxed process.
So you can see that what we've got is all of these sub-assemblies. So there's casting for the back, casting for the front, stamped sides, stamped body panels, and the structural battery pack thing that's in the middle.
Yes.
And so you just paint the parts you need to paint. Which is
which are these, the parts we need to paint, right? Which means a smaller paint booth dedicated to making certain
because you can
parts.
just, like, the whole car has to go into the current paint booths. This is like
yes, and the thing is, a lot of people say, why don't they just dip the whole thing? And a lot of times they don't.
Right.
I was talking to a former colleague who knows a little bit more about this stuff, and he says in some cases they can just do like a full dip of some of these enclosures.
Oh, okay.
Yeah, they may not have to spray paint them.
Right.
So
but again, if you go back and compare this to the other one, you were painting everything. So a lot of wasted,
everything was being painted. Yes.
A lot of wasted effort.
So they already do it for like the corrosion coat and stuff like that. That goes through and everyone assumes that's a painting. It's like, well, it's a kind of painting, but it's not really where the color gets applied. It's just there for a corrosion resistance.
And it doesn't have to look aesthetically particular. Well, I mean, one of the reasons why the painting's so hard is it has to look aesthetically pleasing and there's no mistakes. And so you know, with the underbody coating and stuff like that, the corrosion, it's like if it's splotchy and stuff, no one's ever going to see it, so it doesn't matter. So it's just like
right. It's all going to get covered up. All that matters is it doesn't corrode.
Yeah,
and they're making sure it's made out of material that doesn't corrode.
Right.
But and they may be doing some other treatment that they're putting on there. Because if you remember when we were kids, when you bought a car, the first thing you did is you went to Z-Bart.
Right.
To make sure it didn't rust out. Well, basically they're doing that now when they do that dipping. So Z-Bart doesn't really exist anymore. You don't need to do that.
Right.
Because if the cars are made correctly, everything.
I remember their ad. It was Z-Bart, it's us or rust.
Yes, exactly.
It was very effective. So, but the other thing that's really cool about this is that sort of center assembly line that doesn't require paint.
Right.
Can be done. It's moving along, and all of these painted pieces, I'm assuming that there's a really big challenge of having to make sure that the same batch of paint is being matched up with all the panels and stuff that are being put on. But basically, you know, you get a whole bunch of these things that can be made offline,
right?
You know, sequence. It doesn't have to be done in exactly that sequence. You just get them, you slap them on, and you just keep on going.
And I think it brings up a couple of other interesting things that we might be able to get into a little bit later.
Okay,
when we talk about how
let me just run it and continue here.
Yes. So it goes on.
Putting things
everything starts to drop in.
Right.
It's being and everything needs to be done in parallel. So
you're
able to do all these things at the same time, and then finally you start matching it together.
Right.
And this is going to be the big thing, because when they start to bring the castings together and then they bring in the side body panels, and this surprised me that they don't put the battery module in here first. That comes second. So the side comes in, and right now my first question for Sandy, pause it right there.
Okay.
How are they joining that to the body?
Right.
Because traditionally that's where you spot weld.
Yeah,
because but you don't spot weld when it's been painted.
Right.
So they're using a different joining technique. And the question is, what is that going to be? Is it going to be some sort of fasteners? What is it? You know, you need a lot of integrity there.
Right.
I mean, it's not like you can just put a couple of plastic rivets in there and say, done.
Right.
It's going to be a bit more than that.
Or just goes, just falls
Yes. But Sandy says he's been talking about this for a long time, so he must know exactly how it is. So that means they've got rid of almost the last spot welding robots.
Wow.
And we're going to talk about what's left for spot welding now.
Right.
Where is that going to be?
Is it possible that they could have like little fingers or something like that would stick out and go in, and then you could do something?
They usually have tabs when they do the spot welding. They have these tabs anyways that help line everything up. But that's just to make sure things are lined up where they are, and they may do a little bit of a fold tab just to kind of get it in place before the spot welds come in. But there is no structural integrity in those things. I would not trust my life to those tabs.
No, but that's why I'm wondering,
you need something else. Yeah.
Whether they've done that and created some mechanical like pressing.
They may have done something else. So there's something clever going on there.
Right.
So when I saw that, it's like immediately, okay, all those robots that are usually coming around there, you're seeing all the spot welding. That's the one that the drone video goes through that everyone like absolutely loves that.
Right.
Because it's a centerpiece of the manufacturing.
Right.
Not being done here now. And then the enclosures come in. Now, the enclosures.
Do you remember when they showed computers for a long time that they would have the box with the flashing lights? That was the refrigeration unit for the mainframe. It wasn't the actual computer. So now what we're doing is we're moving to the assembly looking so boring that they're going to have to show like some other stuff. That's
something else. Yeah.
Like
so
it's really
just
cool.
And it really literally is being put together like a toy car.
Yeah. Yeah. Crazy.
And like, I think I joked this morning with you. It's like, I think they're joining it together with Tester's glue.
Right.
That maybe that's what they're using, you know?
So anyway, so this comes together, somehow is attached. The bottom comes on with the seats already in it.
Mm-hmm.
And then you put the top on.
And then everything else. And then the enclosures. Okay.
Right.
Now, I asked my friend about this, who he works for a tier 1 supplier, and they make these enclosures. And a lot of these enclosures, there is a little bit of spot welding, but most of it's actually hemming. So they take the two pieces and they ham them around in the hemming machine. And the only reason they do the spot welding is they're not quite sure that the hemming got everything right. So they're in there more as an insurance policy. And I asked him, says, is that one of those things you could potentially eliminate? He said, yeah, you could get rid of a lot of that. So that means there is always a lot of spot welding going on, not just the robots that are in the middle. There's the spot welding that's happening off on the sides that are making the underbody and everything else. Those have been eliminated by the castings. Right. Now it looks like we've eliminated the ones on the sides. So the only one's going to be left are for the enclosures. Right. And maybe for the side panels a little bit, but they may come up with something else. So I don't know if we're going to see that many spot welding robots, or if if there is welding, it won't be spot welding. They'll use a different type.
Yeah, I guess that's true. They could use maybe
high-end cars are using like laser welding instead. They don't use the spot welding because they want to have a nice long linear bead. Yeah. I was looking, okay, so then we get into the manufacturing efficiency. Right. I guess it's the low voltage system where they talked about this more, but the part that kind of goes along with this whole thing is that when you do this, one of the things that Tesla can do is test the vehicle as they're manufacturing it. Right. By doing it this way, you don't really, the side panels and things like that have very little electricals in them. I mean, you know, some lights in the doors and sensors, but basically every single one of these components, they say later on, I think when they talk about low voltage, all of these components can test themselves. So basically when you put the unit together just by itself, it tests it and goes like, things are going. And then they said they're going to be connecting it all with Ethernet, which is just really basic, you know, thin, flexible cable, just one attachment point for each of these units into the main unit. So, so everything tests itself. It all says it's working. So before you even put the car together, you know it's working. And again, if let's say the front, like the drivetrain in the front or something is broken, while you're building it, you can swap out one that is working and keep the assembly line going and take the other one offline and fix whatever the problem is. So you don't have to have the agility. Yeah. Right. Now the reason why this is called unboxed. Right. When I looked at that, and then the first thing I did is I just sent out a cryptic tweet that just said, "Holy ship."
Yeah, exactly.
And the reason is, and John, you know this a little bit, you know, historically, how did the Vikings build their ships?
Right. Keel, ribs, and then plank it.
You put the keel down first, and then you started putting the ribs on there and everything else. And that was the way ships were always built, right up to like the big ships, like the Titanic and everything else. And then in the 70s, in Japan and Korea, they came up with a novel way of building ships that was so novel, it basically put the American shipbuilders out of business. The only ones that remain are military. And the process they use is that rather than like laying a keel and building everything on there, they built these things called boxes that can be built all around, and then they were joined together. Now, to pull this trick off, remember, this is like cruise ship scale or tanker scale kind of things.
We're talking about
got to have enough tolerance control that you need to make sure both sides kind of match enough. Otherwise, you do that, because when I think some of the European shipyards started to do that, that was like the result of one of their first products. Is like the ship wasn't quite straight, and they had to get that under control. And so the Europeans, they worked really hard because they realized their shipyards are going to go out of business as well if they didn't take this approach. And so they're using this boxed approach, and they're putting it in there. And so when I heard them say box and everything's like, oh, they stole that from the shipyard business right there. That's the way to do it. And it is very clever because you're very parallel. The other thing is, someone today mentioned something about, the cars are being produced at 45 seconds. So the whole idea is your factory, you want one car coming off the line every 45 seconds. That usually means the final assembly line is driving every single station, has to advance every 45 seconds. That puts a lot of pressure on stuff. And we all know that there's always like set up and set down time for anything, that you're just starting on something and now you got to stop and then you got to kind of start again. So there is like time in between there. And that's just like this historic thing. Someone just pulled a number out of the air. It's like, this is what we're going to do. And that means you cannot optimize different parts of the line very well. It's like they are set to the tack time. They are not set to what is the time most optimal for that process. Now with this, you can start doing that because you don't have this long serial line. And if there's a process, it could be more efficient if it's done in 90 seconds. So be it. Let's do it. And we just kind of duplicate two of those things rather than making our line longer. And so I would rather, have these two shorter lines where the tack time is 90 seconds. And then it will be pumping them out a lot faster. Because what will probably end up happening is that when you advance that station, there is the time of advancement. So the whole 45 is like start to end. Which means you might only have 40 seconds in there to do your process. Now, if I can do mine in 90 and it still takes me the 5 seconds to do there, that means I bought another 5 seconds in there for my process, which means that means I'm doing that. At some point, I might reduce myself 1 or 2 stations. So your CapEx goes down, everything goes down. So there's just so many things just taking that approach itself. So in some ways, having a longer tack time may result in you being able to get more out the door. Because in the end, that's all that counts. The number of cars coming off the line. Not what the individual station
and again, don't forget, Tesla is famous for being very agile with their development. And this allows them, if for some reason they want to do the side panel on the left and the right-hand side of the car and change it, they can just do that. It's as long as they have a known stable interface, as long as those little tabs that are fitting into the rest of the vehicle are the same, it doesn't matter what you do with the rest of that part.
And they probably just pull off the side. So let's say those side panels, the process to do that efficiently is 3 minutes. Okay, so we make 5 stations or whatever it is to get us down to the tack time that we need for that. Where all the others, the assembly where they're coming in there, maybe we could still do that in 45. So we only have 1 station that's doing the marriage of everything, but everything else can be done at its speed that it needs to be done. And then we don't have to have duplicated tooling, because you will see that you'll have 2 nearly identical robot cells, the same robots, practically the same clamping, practically the same end of our tooling. And the only reason they're there is just because this one can only get 18 spots in there, and this one gets the other 18, because even though the same robot could, in theory, get all 36 of those spots. and to me, it just drives me crazy. And I could understand why Lars just says, he's looking at this and says, this is crazy. I just don't understand it. And I always had the same feeling of, I'm just a loner. I don't know what I'm talking about. So it's nice to hear that someone is out there who's just looking at it and says, this just doesn't make sense. It made sense 100 years ago. When all you had was paper and pencil to kind of figure it out. And you said, we'll just kind of do it this way. But the cars have got more complex.
And, but I mean, but even, wait, even back to the Model T, the reason why the India Black was the color, that was the only choice in color, was because it was the only paint that dried fast enough. So even back then, the paint was the limiting factor. It was
the limiting factor. And I'm sure they hated it as well. Like, we got to paint this thing?
So I want to point out something here, which I just noticed as we were talking. And I don't know if this is just a sample car, but if this is the next gen car, this looks like it's a rear wheel drive only car. This looks like the engine back here, the motor, sorry, not the engine, the motor.
Yeah.
And this looks like only a steering unit. This looks like,
yeah, but he said this is the Model Y. It was only for example.
Right. I know, but I'm just saying it is interesting seeing that there's because most Model Ys, of course, have two motors.
So
right. It looks different to me. Just making a note. He did say it was just a sample, but I have long predicted personally that they would obviously they're only going to have a single motor because it's expensive to make two of them, but that they would have it in the rear of the vehicle because the steering stuff is complicated enough. You don't need to complicate it more with having a motor in between. Just put the motor in the back. That's simple. It just drives the two wheels and put the steering material like items in the front. So anyway, whether or not that comes to pass with the car, it could be front-wheel drive. But
there's one other quote from Lars, which is interesting. That
here,
when you talk about these in these different stations,
there we go. Okay.
Yeah, is when he was sort of talking about the unboxing. You know, when we go to automate, it will be a lot easier.
Right. And he also said.
Now, what kind of automation is it necessarily going to be? There will be some automation you might be able to do with traditional robotics and traditional automation in there, but it's almost like, we're trying to make it just a little bit easier for Optimus. Now you might say, well, wait a minute, that goes against your thesis that the whole idea is that we want to do the same thing the workers are doing. It's like, well, the workers will still be able to do it.
Yeah.
It's just that it'll be more friendly for Optimus. And in fact, it'll be more friendly for the workers because they were talking about how difficult it was to get those things in.
I mean, you have to like sneak into these things and wire stuff up.
And now all my friends that are like, 50 years or older, they all have back issues.
Right.
There's not one of them that could work in the factory.
Right.
There's not one of them that could do that kind of job.
Right.
So you're really talking about a very narrow workforce that is able to do those kinds of jobs because you have to almost be a contortionist to work in there for 8 hours a day, putting those cables in and getting everything else in. So they are, again, designing for automation, designing for manufacture, which includes automation. That's a big thing. And the other thing about Optimus is designed to be automated by Optimus.
Right. Which was cool. That was part of that video was Optimus building Optimus.
Optimus. And remember what Tom Zhu said when he was talking about
that's what I was just going to get
factory.
Yeah, he was like either people or Optimus.
5,000 people or Optimus. And it was like, and I'm thinking about that. It's like, was he just joking or did he just kind of slip the tongue? And no, what I think happened is that they are planning for this. It's part of their plan and their contingency. So it wasn't just some sort of off the cuff remark. It's just like this design is going to be set up that we will be able to do people or Optimus. And when Optimus is ready. And the same thing with a lot of the other thinking. You probably noticed, I think it was caught by a couple other people when they talked about the next gen, they made it very clear the next gen or this compact model is not the robotaxi.
Right.
It will be the robotaxi in the future, but when it first comes out, it's not going to be the robotaxi without the steering wheel. However, it's designed so that they could quickly change it when FSD is ready. So they are looking at contingencies, making sure it's ready. The same thing, they are designing their next plants around Optimus for all automation. And this is part of the key is opening up the car, unboxing it.
Well, and conversely, they're designing Optimus to work in the factories because you saw it unplugged a cable, it picked up a socket wrench and it picked up another socket and a bolt, so it's clearly being designed specifically to work in a factory, not to do backflips, not to do crazy things, not to walk in a really elegant manner. It's just designed to work in a factory. So
yes, exactly. And all it needs to do, I think, for some of the tasks they're looking at there is just walk a little bit faster. That's all. And that will come. And I think we might want to lay to rest this other thing is that a lot of people have been saying, oh, was that video CGI? And I was like, where's everyone getting this idea? CGI?
People thought that was CGI?
Yeah, more than one person thought it was CGI. And one of them, the reason why is, remember, at AI Day, there was one video that showed Optimus walking. Remember, basically the evolution of the walking.
But that was CGI. that was.
Well, no, that wasn't
you're
CGI.
Talking about the evolution of it? That was definitely CGI.
No, John. From my standpoint, I don't call that CGI. That was an animation that was based on a simulation. So basically, when you do simulations, you create numbers, and people need to look at the numbers. You can put them in a table, and you don't understand it, or you can put it on a graph, and you can see it. But some cases, the best way to look at a number is to animate the thing so you can see it moving.
Right.
And then you use CGI to do the rendering. So a lot of times CGI there's no physics, there's nothing behind it. It just like looks really good and really cool. But if you analyze it, you can see it's completely fake. So that was because they wanted to prove that they were simulating it. And the fact that that simulation was so good that when you looked at the real thing, you thought it was the CGI tells me that their simulation is really, really good. Right. And the other reason that they would not do that is Tesla would never roll a truck downhill.
Right. Yeah. They would have.
Enough said.
Yeah.
No way that's CGI.
Yeah.
No way.
No. Well, but also, I mean, there's just, okay, so this is my day job. I mean, this is literally what I do. Yeah. I not only teach it, but I grade students on how good it looks. And so, you know, it was just like, it's a no-brainer. As soon as instantly in my mind, it was like, that's real. There was tons of clues that it was real. Including the fact that it was very imperfect, unless they were just being super like, oh yeah, let's make it.
I mean, if it was CGI, why not actually show the bolt going in there? You know, there would have been all these other things where the continuity
or get rid of those oscillations, the overcompensation oscillations. Where it was doing this kind of thing.
And there would have, you would have seen that there wouldn't have been multiple takes or something like that. So the scripting, the continuity. So from the standpoint of what it was not scripted, but it was staged a little bit in the sense that they kind of knew what they wanted to do. Let's just go ahead here. Let's get a couple of shots. But Optimus actually did what it was supposed to do on its own, without really being told, just being suggested. Just do this over here. So it was,
I mean, we don't know. They may have been pretty. They may have been like, go over here, pick up this tool, do this stuff.
Right. But that's what directors do. You get a good actor, and you just say, hey, here's your lines. Hit that spot, then go over there and hit that spot. It's as simple as that.
It was actually Anthony Daniels inside the suit. It was actually him.
Yeah, maybe it was.
It's C-3PO.
I think the only thing that threw it off is the fact that the lighting didn't look like you were out in a factory that like you were expecting. I mean, they really get the mood lighting right in there. Yeah. And that there, I think, made some people suspicious because it looked like it, you know, a good director came in there and figured out how to do it. And Tesla's been very good on their videos recently. You know, someone is pumping them out and they know what they're doing. So
I know that clearly they actually hired somebody either who already knew, or they specifically hired somebody who was a better cinematographer. So good for them. Okay, anyway, I will tell you my professional opinion working in the field. There's not a chance in hell that was rendered. That was definitely real. It was just well lit. And I'm sorry.
Yes.
So, you know, it's like going to watch a movie. You expect it to be well lit. You know, you don't expect
it was not an amateur job. That's the whole thing. It just looked too good.
Right. Exactly. Yeah.
So
is there anything else? So basically, okay, so we have parallel instead of serial. So you can feed, not painting extra garbage you don't need to paint, not putting it together and taking it back apart again. The consequences that we don't know is how the hell you put the pieces together without welding them to make them actually stick together.
And I'm waiting for the Monroe video on that.
Yeah. And Sandy probably knows, so we'll wait for that. And then the other part is the subcomponent testing, where each of the pieces knows that it's functional before it's put together.
And they're already doing that now.
Apart again. You don't have to.
They showed that already.
Yeah,
that they're already kind of doing that now. So it's pretty clear they're just going to accelerate that.
Yeah, but they're not going to be using CAN buses anymore. They're going to be using Ethernet, which means it's just a couple of cables that connect up to the main motherboard. So it's really cool.
Yeah. And the thing is you want to test your quality at the source, at the location, and not wait for it to come off the line and say, that's a problem here. And then they start thinking, there's a problem here. Maybe it's way back here. Maybe we got to go check that. And next thing you know, you had like 20 cars that are coming off that are lemons. So you want to be checking it right at the source. And that's the way it is. That's what really gives you the agility. Yeah.
Right. And this should
cost down and everything.
The error rate, the cost of quality, all of that stuff is drastically reduced by self-testing these things. Yeah. I mean, Teslas already do that as they build it. But if you discover after you put the bottom on and a bunch of pieces together that there's something wrong in the middle, it's like you have to take the whole car back apart again to get back to that middle. With this, you find out right away, and it's like, okay, unplug, plug it back in. You know, it works better now, and you don't have to take the whole car apart. So just incredible. I find it so funny that Toyota was like, the Model Y, and it's a work of art. It's like, just wait for the next gen.
Just wait. Yeah, hold my beer. Yeah.
Oh, yeah, that's like
and the thing is that by the time that, they look at that and then they're going to copy that process and then realize, wait a minute, we just got leapfrogged.
Right.
So I don't know if they're going to be sitting there and then it's like, what do we do?
Yeah.
Do we kind of improve the process we have? Do we try to do what Tesla has done? Or are we going to try to guess what Tesla is doing?
Well, and that's what I'm thinking. If they were watching this presentation, if you were one of the higher ups at any other automaker, you'd be like, oh no. Last night, I would have been sitting there watching this section going, oh no.
Yeah. Yeah.
Yeah. So, I mean, they kind of have to like skate to where the puck is going. They have to try to match what Tesla's going to do, but they haven't built it the other way yet. So they don't even know how to build it the old way.
Yeah, you need the experience. I mean, look at what they know with motor drives and everything else, which is absolutely amazing. Sandy was a bit impressed by, I think he said they're using some sort of hairpin for the motor. So they have like a different design, which he thought that she said, oh, they're going to done that. But he didn't say anything about the fact they get rid of the rare earths, which is already also rather amazing. Yeah. And to me, it's like, think about it. There are two big shocks that came out within the past week as far as stuff. One of them is, the rare earths, but back up to SpaceX with argon. And they're using that, which we are going to do a big discussion.
We're going to do a video about that.
That is like, when that's like, and the efficiency they end up using something we're supposed, it's like, how are they getting a motor that's not using rare earths? Just like, how can you get a high efficient Hall thruster with argon? It just doesn't make sense. And it tells me there is something in common there that they are now coming in and coming up with designs.
I will tell you,
and I think I know what the common link is.
Do we want to let's just not give it away. You have to subscribe.
Not give it away. But
we know what we think we know what the common link is.
We think we know what the common link is there, but there is something going on that their design process is accelerating way faster, and it's going to be really hard for anyone to catch up.
Absolutely.
Yeah.
All right. Well, cool. I think we covered this. This was, it's really amazing. Like Investor Day was so full of gems that it's just, when I did that speed through last night, I was just like, oh gosh, this is just like, I'm just mentioning everything. So it's fun to be able to dig into these more and actually have some fun looking at them. So
yeah. And I would love to have Corey on your channel to ask him or Sandy to say, all right, how are you going to join it?
Yeah,
there's got to be some way.
I'll reach out to Corey tonight and see if he or Sandy could come on and talk to. They probably want to talk about it on their own channel first, but maybe we can get them on after they talk about it on their own channel.
Yes, so,
anyway,
absolutely.
Yeah. Absolutely. All right, Scott. Thank you so much for joining me. I really do appreciate it.
Thank you, John. And
always amazing to get your insights because you're so wise about all of this. Thank you.
And remember, we want to pump you up.
Or unbox you up or something.
Unbox you up or whatever.
I'm missing my muscles. I don't feel like I have the strength.
Exactly. What happened to them?
We turned into girly man.
That's very good.
And people, if you're young enough that you don't remember Hans and Franz from Saturday Night Live, go look it up. So yeah, there you go. That's our little gift to you because it's a lot of fun. So there you go. All right. We'll talk to you all later. Bye-bye, everybody.
Bye-bye.